Hey everyone, this is Miss Merlin. Today we're going to be doing a lesson on geometric probability or geometric distributions. So make sure you grab a new note sheet and then you will need to have a graphing calculator. So as I said, today we're doing geometric distributions. So you are going to learn the difference between binomial distributions, which we've been doing, and geometric distributions. Just a reminder, our test is on Tuesday. So please make sure you start on your or get going on your assignments. And I also posted a new AP classroom. So what you're going to do first is try to complete numbers 1 through 12 on the front of your activity sheet. So Brody James is in stats class. He's practicing his act for the talent show, which is bottle flipping. And he says that it's a 20% chance the bottle lands right side up. So you're going to go ahead and work through numbers 1 through 12. Go ahead and pause the video. All right, so just double check your work. Let's first go ahead and talk about why this is a binomial representation to start. So it is binomial first because it is binary. You either can land or not land. All right, it is independent. All right, the number of trials, it says if he flips 10 times, so the number of trials is 10. And lastly, the probability stays the same, which is P equals 0.20, which is 20%. Right? So how many do you expect? We learned this yesterday that the mean is N times P. So we have 10 trials, 20%. You should have gotten 2. The next one, what is the probability he makes exactly 2? P of X equals 2. You can do binomial PDF if you want. All right, and we have 10 trials. Our probability is 0.2, and we want to know exactly 2. You should get 0.3020. Probability he makes less than 2. Right, so this one is a little tricky. We haven't done one like this. So less than 2 is really the same thing as less than or equal to 1. So you would use binomial CDF, but you wouldn't go to 2. You would just go to 1, and you should get that. And last, what is the probability makes at most 2? So that is equal to, you can include the 2. So you do the same thing as above, binomial CDF, but you would do up to 2. So remember, it's your number of trials, your probability, and the value can go up to for the CDF. All right, so now we're changing the scenario. Now the teacher's getting annoyed. So she says he can flip the bottle as long as until he gets it landing upright. So it could be 2 times he gets it, 5 times he gets it, 10 times. So what's different is it no longer fits the binomial conditions because the number of trials isn't fixed. So we don't know how many trials he's going to do. It's unknown. So then it's no longer binomial and it changes to a geometric distribution. So the probability it lands on the first try is just 20%, 0.2. Probability it lands on the second try, so the opposite, he means he must have failed the first time, which is 80%. And then he had success the second time, which is 20%. So that gives us 0.16. That he fails the first 2 and lands the third, that would be fail, fail, success. Multiply those together. And again, each time we're just adding a failure probability until he reaches success on the last try. So go ahead and check the table. I just finished 5. It's the same thing. You should notice that we have K minus 1 fails and then 1 success. So this is the failures. This is the success. So last question, how many fails would you expect it to take for a bottle to land right side up? Why? Well, the probability is 20%, which is 1/5 as a fraction. So 1 in 5 times. So I would say out of 10 times, it would take him 2. So how many flips would you expect it to take for the bottle to land upright? 1 out of 5 times. So he should get it within 5 times, it seems. I take back what I said. All right. All right, so now we're going to do some notes. So go ahead and take these on the in the summary. So a geometric random variable is different from a binomial is because we don't know the number of trials. You just do the number of trials until you reach success. So the only letter that changes is instead of bins, it's bits. So instead of the number of trials being fixed, it's trials until success. And just like there's a binomial CDF, there's a geometric PDF and CDF. I don't really use the geometric PDF because it's easy to calculate the probability for a geometric when it's exactly equal to a number. And then here's the formula like we just did. The probability of X equals K is equivalent to failure probability to the K minus 1 and then the 1 success probability. And the mean of a geometric is 1 over the probability. So similar to that 20% is 1 in 5. We could have also gotten 1 in 5 by doing 1 divide 0.20, which gives us that as well. All right. Standard deviation of the geometric distribution is the square root of the failure probability divided by the success probability. So make sure you pause the video and get those formulas down. We're going to do one more example. So pause the video and give this example a try based on what you just learned. So Mason never has a pencil when the test comes, and it's only a 15% chance that students will give Mason a pencil when asked. So Mason's going to begin randomly asking students for a pencil. Y is our variable, and it's the number of students Mason asks until he finds someone who will give him a pencil. So first, let's talk about why it's geometric. It's binomial or binary. He either gets a pencil or he doesn't. Doesn't matter how many people he asked. Each trial is independent. All right. We are doing trials until success. So once he gets a pencil, he's going to stop asking. And the probability is going to be 15% for each trial. Right? What is the probability the third person asked is the first person who gives him a pencil? So we're looking for the probability that exactly 3. So you can use geometric PDF, but I think it's just as easy to use the formula. So it's going to be a failure, which is 0.65. I lied. I can't do math at this time. 15%, the opposite is 85, excuse me. So he's going to fail, and then he's going to have success. So you could also write that as 0.85 to the second times 0.15. Right, so I'm going to calculate that. 0.85 times 0.5. And so I get 0.1275. All right, what is the probability he gets a pencil by the third person? So he could get it on the first, second, or third. So the difference is it is less than or equal to 3. So I'm going to use my handy calculator and say it's geometric CDF. And geometric CDF doesn't have the number of trials like the other one. It is just the, not n. It doesn't have the n. It just has the probability and the x value. So it's going to be geometric CDF. The probability of success is 0.15, and we want to know by the third person. It's found in the same spot, second vars. It's the very last one. I don't want to go past it. Oh, I just went past it. Thank you. Clear. All right, geometric CDF, and we have probability of 0.15, and we want to know by the time he gets to 3 people. That probability is 0.386, we'll say. It's a decimal. All right, next one, how many people would he expect? So we just learned this. So mu of y, the mean of y is 1 over p, which is 1 over 0.15. So that's going to give us 6.67 people. So he can expect to ask around 6 to 7 people. So now he's asking, should he be surprised if he didn't receive a pencil until he asked at least 10 people? So we want to know what's the probability he has to ask 10 or more people, which is the same thing as 1 minus the probability of 9 or less. So we are going to do geometric CDF of 0.15 comma 9, and then we're going to do 1 minus that at the end. So we are going to do that. Oops, I did that wrong. Change it to 9. All right, so the probability he gets it in 9 people is 0.768. So then we're going to do 1 minus that to find the probability that he has to ask more than 10 people. So 1 minus that is 0.2316. So he shouldn't really be that surprised because 23% is not that low. He might have to ask more than 10 people. And last, we're going to practice the standard deviation. So standard deviation of y, remember the formula is 1 minus p over p, the square root of 1 minus p over p. So our failure probability is 0.85. Square root of that divided by 0.15. Right, that divided by 0.15 gives me a probability of 6.14. Right. All right, so go ahead and try that last one on your own, and you can get working on the practice, and there is an AP Classroom posted.